Good afternoon, class. We are looking at Module 5, which is part of the final exam. Here's the chapter about sequences and series. Sequences and series. Write the first 5 terms of the sequence a sub n equals 9 times 1/4 to the power of k minus 1. Well, all we have to do is replace the n with numbers 1 through 5. So let's start with number 1. 1 minus 1 makes it 0. 1/4 to the power of 0 is 1. And so the answer is 9. Let's replace that with number 2. So that means simply 1/4 to the power of 1 is 1/4 times 9 is 9/4. That's the second one. If we can figure out the first two, that means we can figure out the rest of them. So all we have to do, replace the k with 3, 4, and 5. And we have the final answer. Here's the sequence. A sub n is a 2, a sub n minus 1 plus a sub n minus 2, where a sub 1 is defined to be number 6, and a sub 2 is number 3. So first and foremost, what are we dealing with? A difference equation or recursive sequence is an equation of the form a sub n plus 1 is f of a sub n, where a sub 1 is given and f is a real valued function. A solution is a sequence, a sub 1, a sub 2, all the way to a sub n, satisfying the given difference equation. The way it works, in this case, they want us to write the first 5 terms. We already have the first and the second one. So let's figure out the next one. So if we change this to 3, we want to see what happens. So you write the formula, a sub 3 is 2a sub 2 plus a sub 1. In other words, you replace, if you replace this one with 3, then it's 3 minus 1. This is 3 minus 2. And this is how we arrive at a sub 3. Based on the general definition, we can find the specific definition. 2 times a sub 2, that means 2 times 3, which is 6, plus a sub 1, and that's another 6. They add up to 12. Let's do one more. We want to go with a sub 4 here. So if we change this to 4, this becomes 4 minus 1. Let's write it. We change this to 4. This becomes 4 minus 1. This becomes 4 minus 2. So a sub 4 is 2a sub 3 plus a sub 2. So 2 times a sub 3, 2 times 12, plus a sub 2, 3. So 2 times 12 is 24, plus 3 is 27. And again, we can easily find the rest of it. So 6 and 3 were given. We came up with 12 and 27. I leave it for you to come up with the last one, which becomes number 66. Determine whether the sequence is arithmetic, geometric, or neither. If the sequence is geometric, find the common ratio. So first, let's refresh everyone's memory about arithmetic sequence. When it's defined recursively, a sub n plus 1 is a sub n plus d. So just add a constant, or explicitly by a sub n equals a sub 1 plus n minus 1 times d. Whereas a geometric sequence, we add a constant for arithmetic. For the geometric sequence, we multiply by a constant known as a ratio. So a sub n plus 1 is r times a sub n, or explicitly, a sub n equals a sub 1 r to the power of n minus 1. So when we look at this one, we may notice that there is a relationship between those, among those numbers. So if we divide this one by this one, so a sub 2 divided by a sub 1, divide the second one by the first one, we get -2. This is not good enough. If we divide the third one by the second one, we get the same, and you can continue just to be on the safe side. And that shows that R, the common ratio, is -2. Therefore, it's a geometric sequence. You may notice here that we are adding a constant from one format to the other. So if we add 2, but then we have to add 3 and then 4, so it's not a constant. So we are not adding the same number. If we divide 8 divided by 6, 11 divided by 8, we notice the ratio is not the same, 8 over 6, 11 over 8, 15 over 11, and so forth. We notice the difference is not a constant either. So a sub 2 minus a sub 1 makes it 2, but a sub 3 minus a sub 2, 11 minus 8, that makes it 3. They're not equal. So it's neither an arithmetic sequence nor a geometric one. This one, we probably recognize there is a relationship between the ratios, if you will. If we divide the second by the first one, a sub 2 divided by a sub 1, 1/2 over -2 becomes -1/4. If we divide a sub 3 over a sub 2, that gives us -1 over 8 over 1/2, which is also -1/4. So we have a common ratio of -1/4, which makes it a geometric sequence. Write the arithmetic sequence 32, 24, 16 in the standard form, meaning find a sub n. So again, just reminding you that a sub n plus 1 means a sub n plus d, a constant distance, they call it, or a difference, or in general, a sub n is a sub 1 plus n minus 1 times d. So notice the first term, a sub 1, is 32, and the difference here and you look at the difference here just to make sure they're identical, and it's -8. So because it becomes smaller by 8, 24 minus 32 is -8. So we can use this general form, a sub n equals a sub 1, meaning 32, plus n minus 1 times the d, meaning -8. So we're going to replace the a sub 1. We're going to replace the d with -8. And over here, we get -8n plus 8. And 32 and 8 add up to 40. So -8n plus 40. The general. Fill in the blank. 139 is which term of this arithmetic sequence? So first and foremost, notice it's an arithmetic sequence with this general case, and the first term, a sub 1, is 1. The d is 4 minus 1, 7 minus 4, 10 minus 7, it's +3. Okay. And so we put that into this formula. We replace the a sub 1 and we replace the d with what we've come up with. Obviously, this is 1 plus 3n minus 3, and we can add 1 and -3 into -2. So that is the general form. A sub n is 3n minus 2. So what term is this? All you have to do is set this up to equal to 139, solve for n. So we move the -2, make it +2. So they add up to 141, and we divide by 3, and becomes 47. All right, let's answer the following questions. Find the formula for the general term a sub n of the sequence, assuming the pattern of the first few terms continues. So if this continues, we want to see what's going on. It's either a geometric or arithmetic sequence. We notice there's a ratio. So if we see that a sub 1 is 0.8, we can look for, so that's a sub 1, we can look for either the D or R. So we can look at their difference, we can look at the ratio, and if we divide 4 by 0.8 and 20 by 4 and 100 by 20, we notice they give us the same answer, which is 5. Therefore, you're dealing with a geometric sequence. And with that being the case, we can use this formula. A sub n is a sub 1 r to the power of n minus 1. We replace the a sub 1 with 0.8 and r with 5. We want to find a sub 8. All we have to do, replace this n with 8, which makes it 0.8 times 5 to the power of 7. And you raise 5 to the power of 7 multiplied by 0.8, you get the value for a sub 8 to be 62,500. Find the 9th term of the geometric sequence whose initial term is a sub 1 equals 4, and the common ratio is 2. So again, the general form a sub n is a sub 1 r to the power of n minus 1, where a sub 1 is 4 and r is 2, and we want the 9th term, n equals 9. So we are going to replace the a sub 1 with 4, r with 2, and then n with 9. Obviously, this makes it 8, 2 to the power of 8 times 4, or you may recognize that as 2 squared, so 2 to the power of 10, which is 1024. You may notice this is 8, this is 2 squared, so you could rewrite this as 2 to the power of 10, because you may know that 2 to the power of 10 is 1024. I'm going to evaluate the sum. So we're going to replace the k with number 3. Then with 4, 5, 6, all the way to whatever the upper limit of this summation sign is. So the lower limit is 3, so replace it with 3, then 4, then 5, and add them up. This is the summation sign, sigma, the Greek letter sigma. And so 3 squared, this is 9 minus 1, 4 squared, 16 minus 1, 25 minus 1, 36 minus 1, 49 minus 1, and you're going to add them up, and you get 130. Write the arithmetic sum using sigma notation, 9 plus 4 plus -1 all the way to -26. And again, reminding everyone that a sub n plus 1 is a sub n plus d, the common distance or difference. That's recursively, explicitly a sub n is a sub 1 plus n minus 1 times d. So we are really looking at that one, and we put it in some sort of a summation from lower limit to upper limit. So what would be the k² minus 1, whatever we come up with here. So first, so in essence, we want to write the summation of a sub n from n equals 1 to n. We have to figure out what n is. We'll do that in a moment, but first and foremost, the first term is 9. Then we are adding -5. In other words, 4 minus 9 is -5. And you notice it does the same thing here. So A1 is 9, D is -5. Over here again, what do you add to 4 to get to -1? -5. So it's a good practice to really check and recheck. And so we are going to replace the A sub 1 with 9 and D with -5. When we do that, distribution gives us -5 and +5 here, and 9 and 5, they add up to 14. So now we have the A sub n here. But what we need to find is n, and since we are going to go all the way to number -26 as the last number, we're going to set this one equal to A sub n, which is this number, to find the value of n. So this last number that we have here, we don't know which term it is. So we just set it equal to the general term, and you solve for n. You move the 14, so you're going to subtract 14 and you get -40. You are going to divide both sides by -5. N becomes 8. And now over here, we got A sub n, and we have the n equals 8. We're going to replace it, and that's the final answer. So this is how you write the arithmetic sum using sigma notation. I'm going to evaluate this one from 1 to 40. Well, we can go through the process and let n be 1, then 2 and 3 and so forth, and add them up. We can do that. But we can notice that this is a geometric sequence, and therefore there's an easier way. So in order to make sure we understand it's a geometric sequence, let's write the first few terms. For example, if n is 1, this becomes 0. To the power of 0 is 1, so it's 3. If n is 2, 3 times 2 is 6. If it's 3, 12, so on and so forth. So you write those, and that shows immediately A sub 1 is 3, or is 2, you may recognize it from here, or 6 divided by 3, 12 divided by 6. And then we look at this general formula now. In the case of a geometric sequence, S sub n is A sub 1 times 1 minus r to the power of n over 1 minus r. So if we use this formula, we can get to the answer faster instead of going all the way to 14 and add them up one by one. So we're going to replace the A sub 1 with number 3, or with number 2, as I mentioned. So A sub 1 is 3, or is 2. And then n, 2 to the power of n. And what is n? 14. And at this point, you raise 2 to the power of 14, subtracted from 1 times 3, divide by -1, meaning change the sign. This is a simple calculation. Putting into a calculator results in 49,149. However, if you wanted to continue with this and all the way to the 14th term, it would take a lot longer. So this concept is known as partial sum up to a certain number, in this case 14. In this case, when we say S11, in essence, if we had it in this format, this number would be 11. That's the concept. Find the partial sum for an arithmetic sequence or for a geometric sequence. So that means up to the 11th term. And S sub n For an arithmetic sequence, there are two formulas: n over 2 a sub 1 plus a sub n. Or if you replace the a sub n with this, becomes n over 2, 2a sub 1 plus n minus 1 times d. And if you happen to have the first and the last term, it may be easier to use this one. If you don't have it, it's easier to use this one. So we are going to use this one, replace the a sub 1 with 9, d with 3. And since we want s sub 11, s sub 11, n is 11. So this means n is 11. We replace them, and 11 minus 1, 10 times 3 is 30, 2 times 9 is 18. They add up to 48. Divided by 224 times 11 is 264. Find the infinite sum, if it exists, for this geometric sequence, meaning it may go to infinity or negative infinity, and therefore it doesn't exist. But if it settles down with a number, it does. And it so happened, if we look at the geometric sequence, the sum S sub n has this formula: a sub 1 times 1 minus r to the power of n over 1 minus r. If r has a value somewhere between negative 1 and 1, as n goes to infinity, this goes to 0. So if you have a fraction, for example, 1/2, and you raise it to the power of 2, becomes 1/4, becomes smaller. So ultimately becomes 0. So it becomes a sub 1 over 1 minus r. So first, let's figure out the two things. What is the first term? Clearly is negative 2. And let's find the r. So by dividing this number by this one by this one. So to find r, when we divide 0.5 by negative 2, that means 1/2 over negative 2, or negative 1/4. If you divide this number by 0.5, gives you the same result. You really have to check both to be on the safe side. And this number is somewhere between negative 1 and 1. This number is between negative 1 and 1. So we can use the s sub n here, or they sometimes use s sub infinity. Okay. And negative 2 over 1 minus negative 1/4. As you can see, they add up to plus and becomes 5 over 4. And of course, you multiply by the reciprocal. Negative 2 times 4, that means negative 8 over 5. Find the infinite sum, if it exists, the summation of 1 to infinity. That's another notation. I wanted you to be comfortable with the notation. 1/4 the power of k minus 1. So we should recognize, just in this format, this is a geometric sequence with the first term being 9 and 1/4 being r. But just to be on the safe side, let's start. If you plug in 1, you can't assume it's always 9. Plug in 1, and that becomes 0. 1/4 to the power of 0 is 1 times 9 is 9. If you plug in 2, becomes 1/4 times 9, 9 over 4. If you put 3, 3 minus 1 is 2. 1/4 squared is 1 over 16 times 9 is 9 over 16. So I'm going to assume you can go from here to here by putting the first few, which tells you clearly the first term, a sub 1 is 9, or if you divide this one by this one, or you just, this should show you that r is 1/4. Again, it's between negative 1 and 1, which means we can use the general sum when n goes to infinity of a sub 1 over 1 minus r. So let's plug in. Now this becomes 3/4, and then 4 times 9, 36 divided by 3, or 12. because when you divide by a fraction, you multiply by its reciprocal. On each swing left to right or right to left, a pendulum travels 90% as far as on its previous swing. If the first swing is 10 feet, determine the total distance traveled by the pendulum before coming to a complete stop. So going back and forth. So if the first one is 10, then the next one is 90% of that, 9 feet. And then the next one is 90% of that, 9 times 9, 8.1 feet, and so forth. So you're dealing with the geometric sequence with a sub 1 being 10 feet or being 0.9. And since R 0.9 is between -1 and 1, we can use this easy way out by replacing a sub 1 with 10 foot and or with 0.9. We can come up with the answer. As you can see, 10 divided by 0.1, which means 10 times 10 or 100 feet. You use the same unit. Whenever units are given in the case of applications, you must answer with proper units. A ladder consists of 31 rungs if the rungs taper uniformly from 18 inches to 28 inches. How much material would be needed for the 20th rung? So it starts from somewhere. There are a total of 31 rungs. And when it starts, it's at 18 feet and it gets larger and larger uniformly. And the last one is 28 inches, which indicates we are adding a common value, a common distance, and therefore we need to be concerned with the arithmetic sequence. So notice that we have an arithmetic sequence. Therefore, AS, short for arithmetic sequence, N is 31 because there are 31 rungs. The first one, A sub 1, is the smallest one, 18 inches. The last one, the largest one, is 28, so A sub 31. And then we are interested in A sub 20. So understanding the concept and the question. So we use this A sub N equals A sub 1 plus N minus 1D. And we're going to use A sub 31 equals 28. And that will help us come up with the D, because we need the value of the D. So A sub 31, according to this formula, is A sub 1 plus 31 minus 1 times D, where A sub 1 can be replaced with 18. In other words, replace the N with 31, replace the A sub 1 with 18, and A sub 31 with 28. So I hope you realize this is 30D, this is 28, this is 18. Subtract the 18, you get 10. And when you divide by the coefficient of D, namely 30, you get 1/3. And of course, it's 1/3 of an inch. That means we are adding a constant distance or difference of 1/3 of an inch. Same units, 1/3 of an inch. So we are looking for A sub 20. A sub 20, we use this formula, A sub 1 plus 20 minus 1 times D, A sub 20, where A sub 1 is 18, and we found D to be 1/3. So this makes it 19/3. 19/3, or 6 1/3. 6 and 18 gives you 24. 24 1/3, 24 and 1/3. Units are extremely important. If they are given, we must give them back with the proper units. 24 and 1/3 of an inch. How much material would be needed for all of these 31 rungs? That means we want S sub n. So since we have the first one and the last one, we can use this formula instead of this one, where A sub 1 is 18 and A sub n is 28, right? A sub 31. So we can use that. Bear in mind that in this case, n is 31, everybody. (18) and 28, they add up to 46. 46 cancels out the 2. 23 times 31 is 713. Again, units, 713 inches. Let me remind you of the factorial symbol and binomial theorem. If n is larger than or equal to 0, the factorial symbol n factorial is defined as follows. 0 factorial is 1, 1 factorial is 1, and n factorial is n times n minus 1 all the way times 3 times 2 times 1, all the numbers before that. At any point, n factorial can be n times n minus 1 factorial, or you can say n times n minus 1 times n minus 2 factorial. Whenever you stop, you can put a factorial. And this is a combination formula. There are 3 ways of representing n comma r in a parentheses, CNR, or parentheses up and down NR, n factorial over r factorial times n minus r factorial. So as an example, if we want to simplify that, one easy way, we notice 12 is larger than 10. So we keep the 10, remember 10 factorial means 10 times 9 times 8 all the way to 1. But instead of that, we can keep it as 10 factorial and write this one as 12 times 11 times 10 factorial. And now we can cancel these two. 12 times 11 or 132. The binomial theorem, x plus a to the power of n, you can write combination of n choose 0, x to the power of n, combination of n choosing 1, x to the power of n minus 1, a to the power of 1. You continue. The next one would be a combination of n2, x to the power of n minus 2, a squared, all the way to the last one, combination of n choose n, a to the power of n. In other words, this one, x to the power of 0, which we don't write. A couple of them to remind you, for example, a plus b squared. Everybody remembers a squared plus 2ab plus b squared is really one of those binomial theorems. If we raise them to the third power, a cubed plus 3a squared b plus 3ab squared plus b cubed, that's another binomial theorem. And it's the other way you can write that, you can write it with a summation going from r equals 0 to n. You write this combination formula, and x starts, this is x, to the power of n minus r, because this is x, and a to the power of r. So for example, if r is 0, this becomes n minus 0, or n, this becomes a to the power of 0, which is 1, and that's the first thing that you end up with because n0 is 1. Now, a couple of things that I want you to work on. You can show that n0 combination of n choose 0, combination of n choose n, they are identical and they are both equal to 1. So this ends up being 1. This ends up being 1 always. Then this is n, that means this is n. The other thing that helps, combination of n choose r is the same as combination of n choose n minus r. If these two numbers, whatever they are, they add up to n, then their combinations are identical as far as the top number is the same. And I highly recommend you try that. Now, so again, reminding you of this formula, that formula, this formula, and we want to raise this to the power of 4 using either this method or that method, it doesn't matter. So sticking with what we have here, please pay attention to what's going to happen. It is extremely important not to assume this is x, because it can be anything. In this case, it's 3y, and you have to keep that in a parenthesis for it to work. So notice what's going to happen. So according to this, 4, 0, and then whatever this is, assume it's x, but you have to keep it in a parenthesis, to the power of 4. If you want to stick with this one, remember, 2 to the power of 0. That's where it goes. In fact, if I wrote that, it wouldn't make any difference. If I wrote times 2 to the power of 0, makes no difference. So what I'd like you to know, before we discuss that, notice the exponent on this goes down, and the exponent on this goes up. So this becomes 3, this becomes 1. And again, let me just put 1 here so you notice that. So this is 2 to the power of 1. But there's some must always be n, 1 and 3. So if you look here, see the exponent is 2 here, this one is 2. So this is going down 1, this is going up. This is going down to 1, this is going up to 3, and 3y to the power of 0, which makes it 1. So 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. Of course, this, remember what I told you, this and this are 1. If you go back to the notes, this is 1, this is 1. This is n, which is 4. So this is clearly easy to remember. And what I want you to notice that these two are the same because the combination of 4 out of 1 versus 3, 1 and 3, they add up to 4. So if you calculate this, this is good enough. And you can calculate that. I'm going to show you, for example, the calculation on this one. So if I want to calculate this, is 4 factorial over 1 factorial times 4 minus 1, or 3 factorial, which makes it 4 times 3 factorial divided by 3 factorial, which is 4. Okay. If I want to show you this one, four factorial over r factorial, which is 2 factorial, times n minus r, 4 minus 2. So that's another 2 factorial. So the bottom is 2 times 2 because 2 factorial is 2 times 1. Okay. So 2 times 1, 2 times 1. The top is 4 times 3 times 2 times 1. And 4 cancels out the 2 times 2. And we end up with number 6. I'm going to erase the mess. So this one is 1, so is this one. This one is 4, so is this one. And this one I showed that it's 6. Now, pay attention to the fact that we put this in a parenthesis, because if we don't, and I've seen students do that, if you put 3y to the power of 4 without the parentheses, then you end up with 3y to the power of 4, not 81, because 3 to the power of 4 gives you 81. That's why you must keep it in a parenthesis. So that's a common mistake you want to avoid. That's why you end up with 81y to the power of 4. 3y cubed, 27y cubed. 27y cubed. 3y squared, 9y squared. So on and so forth. And now you simplify, you end up with the following answer. 3y plus 2 to the power of 4 becomes 81y to the power of 4 plus 21 216y cubed plus 216y squared plus 96y plus 16. That's the final answer. This was a typo. All right, we can expand this to figure out that it says find the seventh term in the expansion of y plus 3 to the power of 8. You can always do that by simply raising it to the power of 8, following this format, using this, using that, write all of them, and then whatever the seventh one is. That's one way to do that. Or you may notice the general format, and let's write down the general format for this one. So y plus 3 to the power of 8 is the summation r from 0 to 8 of n factorial, which is 8 factorial over r factorial, times 8 minus r factorial. This is n minus 8. So this one, and this one is the same. Y to the power of 8 minus r, 3 to the power of r. This is what I'm using, okay? Remember what's going to happen. The first term, r is 0. We start with 0. The second term, r becomes 1. So what happens to the seventh term? R must be 6. So you use this one, this formula. Replace the r with 6. That's all you have to do. You can also use this formula that says, based on the expansion of x plus a to the power of n, the term containing x to the power of j is n over n minus j, a to the power of n minus j, x to the power of j. Either one is fine. I think this is a very easy way to approach it. So with that being the case, let's replace the r with 6. So we have combination of 8, 6. That's the idea. Y to the power of 8 minus 6, 8 minus 6, 3 to the power of 6. So you have 8, 6, or you can write 8 factorial over 6 factorial times 2 factorial. That's what it is. This or that, right? According to this. And now, to simplify this, 2 factorial is simply 2. 6 factorial, we're going to keep it. And we're going to change 8 factorial to 8 times 7 times 6 factorial. And the reason we stop at 6 factorial because we can drop this. 2 are identical, we can drop it. And 8, remember this is 2. So this becomes 4 times 7, 28 times 729 y squared becomes 20,412 y squared, which is the final answer.